The next topic we're going to talk about is section 7, which is on the rational roots theorem. This is I sometimes call it the P over Q theorem. So this is when you can't factor something. So when you look at an equation and you're like, I have no idea how to factor this. This will help you find the zeros or the x-intercepts. So basically, if you have some kind of curve, you're finding the points where it crosses the x-axis. Okay, so on this first one, I have x cubed plus 4x squared plus x minus 6. So most would try to factor by grouping first, since there's 4 terms. So you would try to split the middle. But when you pull out the common factors, you'd have x plus 4 left. And then over here, you just have x minus 6. So you need those to be the exact same thing in order to factor by grouping. So we can't do that. So we look for P and Q. So P is going to be all the factors of the very last number, so the constant. So P could be 1, 2, 3, or 6. And it can actually be plus or minus all of those, because you have negatives as well. Q is all the factors of the first number, so the leading coefficient. So it's 1x cubed, so it's just plus or minus 1. So that means all my possible rational places that it crosses the axis, so if this was going to be a fraction or a whole number or an integer, the only things that are possible are of the form P over Q. Now there could be other zeros. You could have square roots, but that's not going to happen very often. So, well, it will happen pretty often. I guess I need to rephrase. But we're going to try to find the possible rational ones first and hope that we can factor to find those other ones. All right, so I could have plus or minus 1, 2, 3, or 6. And it's all over plus or minus 1, so it's just 1, 2, 3, 6, negative 1, negative 2, negative 3, negative 6. Okay, so we test these with synthetic division. Now we're finding when we're getting the zeros. So if you just plug in your numbers, you can check that way. So the first one I always try is 1. So notice if I plug in 1, I get 1 plus 4 plus 1 minus 6. Well, that equals 0. So that means that you have the point 1, 0 on your graph. Okay, so it's going to work. But we're not really just worried about if it's going to work or not. We're really worried about if we can factor it further. So 1 works, so I'm going to put that in the backwards L with my synthetic division. I put 1x cubed, 4x squared, plus 1x minus 6. Now I will say, for those of you that are freaking out right now, thinking, oh my gosh, I hated P over Q. This is going to be so hard. I can't believe I have to use this in AP Calc. You don't use it very often in AP Calc, so don't freak out too much. So you can drop the 1. I have 1 times 1, so I get 1. Add straight down, I get 5. 1 times 5 is 5. Add straight down, I get 6. 1 times 6 is 6. Add straight down, I get 0. This is now factored into my divisor, which comes from here. The 1 gives me x minus 1, because if I plug in 1, I get 0 out like I wanted. And then my quotient. So my quotient is right here. And that's going to be 1 degree less than what we started with. So since my first degree was 3, I'm going to have x squared now plus 5x plus 6. Well, I know how to factor further. I get x minus 1 times, this one's kind of a tricky one to factor. It's actually plus 2 and plus 3. Some people think 6 and 1 because they're like, oh, well, those 6 and 1 can combine to be 5. But you would need positive 6 and negative 1, so you wouldn't get this positive out there. All right, so that means that my factors are 1, negative 2, and negative 3. So those are my zeros. All right, same thing for number 2. Remember from Algebra 2, I did tell you you can kind of cheat. So if you want to, you can go to Grapher or use your graphing calculator, especially on the AP test, because half the test will be graphing. So that will be good if this does pop up on the AP test, which rarely. So you're going to go to Grapher. So I just want to show you on the computer. Oops. All right, and I'm going to put in that equation. So I have x cubed, so x caret 3, so caret is shift 6, plus 5x squared minus 2x minus 24. When I graph it, when I look at it, it looks like it's going to be maybe 2 and negative 3. where you have zeros, and there could be more. I mean, you could have some off to the side here. We don't really know. Since x cubed is probably just doing this like x cubed shape, so those are probably your only ones. Oh, and over here. So I guess so these are going by 0.5, so maybe -4 as well. So I would definitely try 2 and -3 and -4. Now remember, these could be rational roots. So if you look at it on your itty bitty graphing calculator screen, it could look like 2, but it might be like, I don't know, 8/5. You never know. Okay, so I would try those for number 2. Next up. Okay, same thing. So let's try one that's kind of hard. It's like number 6 looks pretty hard. Number 6 is one that you're just going to keep breaking down, breaking down, breaking down. So when I look at it, I realize that I probably can't plug in 1 and get 0 out because it's always plus. So I actually can't plug in any positive number. So when I do my P over Q, I get plus or minus factors of 30. So 1, 2, 3, 5, 6. I'm doing like the rainbow method, I always call it. 15 and 30. And then Q is plus or minus 1. Wasn't I nice? I always made Q plus or minus 1 on these. I should have made it harder. All right, so I don't want to try any positives. I want to try negatives. So let's try -1. So I have 1, 11, 41, 61, 30. -1 times 1 is -1, add straight down, I get 10. -1 times 10 is -10, add straight down, I get 31. -1 times 31 is -31, add straight down, I get 30. -1 times 30 is -30, add straight down, I get 0. Wow, that was lucky. All right, so now I am now going to write in its factored form, which was x plus 1, because -1 makes it 0. And then I started with x to the 4th before, so now I'm going to have x cubed. So 1x cubed plus 10x squared plus 31x plus 30. Okay, since it's 4 terms, you would think you could split the middle, but in this case you actually can't. So we need to do it again. Still can't try negatives. I don't know if -1 is going to work on this one. You can kind of plug in. I'd have -1 plus 10 minus 31 plus 30. Does it work? Nope, not going to work. So you could try -2, -3, but you know, there's a lot of possibilities. So this would be a good case where I would plug it into Grapher. So let me pause real quick and I'll go ahead and put it in Grapher. Okay, so I have our factored form in Grapher, so x cubed plus 10x squared plus 31x plus 30, and it looks like it's crossing maybe at -2 or -3, and like I said, nothing on the positive side. So let's go ahead and try -2 in our synthetic division next. So when I try -2, I'm just trying in the last factored form. So I'm doing 1, 10, 31, 30, and that's it. Now, a lot of people are lazy and they just do the backwards L here and then draw the line and keep going. It doesn't matter. If you want to do that, you can. Okay, drop the 1. -2 times 1 is -2, add straight down, I get 8. -2 times 8 is -16, add straight down, I get 15. -2 times 15 is -30, add straight down, I get 0. So I now have x plus 1 still, x plus 2, x squared plus 8x plus 15, and from there I can see that it factors into x plus 3 and x plus 5. So we're finding when it's equal to 0. So it's equal to 0 at -1, -2, -3, and -5. So those are your 4 solutions, and that's it.